Hello my dear friends and welcome to our today's class. It's our 6th lesson on the 5th topic of Form 3 work, which is called Current Electricity 2. As usual, let me commence by giving you the quote of the day, which states that self-discipline dictates your level of success. We shall discuss that quote at the end of our class today. So today we are looking at combined series and parallel arrangement of resistors. So let's start by looking at this example, which reads that calculate the effective resistance for the circuit below. So our circuit is, we have a 19 ohm resistor, which is connected to 30 ohm resistor and 70 ohm resistor. Now remember, from our previous class, we did say that whenever resistors are connected across each other, then we say that we are talking of what we call parallel arrangement of resistors. But whenever resistors are connected along each other, then we talk of series arrangement of resistors. So to break down this particular circuit, we usually combine the ones that are in parallel in such a way that we end up with all resistors being in series connection. So let's start by breaking down, combining the 30 ohm resistor and the 70 ohm resistor. So because the 30 ohm resistor and the 70 ohm resistor are in parallel arrangement, that is, they are connected across each other, and we know that for parallel arrangement, effective resistance, that is 1 over R effective, must be equal to the reciprocal of the first resistor plus the reciprocal of the second resistor. Therefore, because 30 ohm resistor and 70 ohm resistor are in parallel arrangement, therefore 1 over R, that is the resistance through the 30 and the 70 ohm resistor, will be equal to 1 over the resistance for 30 ohm resistor plus the reciprocal of the 70 that of the resistance through the 70 ohm resistor. So this is the formula that we use to calculate for effective resistance for two resistors which are in parallel arrangement, such as the 30 and the 70 ohm resistor in this case. Therefore, 1 over resistance through the 30 and 70 ohm resistor will be 1 over, remember the resistance through the 30 ohm resistor is simply 30 ohm plus 1 over resistance through the 70 ohm resistor is just 70 ohm. So if you take the sum of 1 over 30 plus 1 over 70, you'll simply get 1 over 21. Therefore, 1 over resistance through the 30 and 70 ohm resistor is equals to 1 over, that is 1 over 21. So if I take reciprocals on both sides, I'll simply have R through the 30 and 70 ohm resistor divided by 1 being equal to 21 divided by 1. So if I take reciprocals on both sides, I'll have R through 30 ohm and 70 ohm resistor divided by 1, which is just the same as R through the 30 and 70 ohm resistor being equal to 21 ohm. But remember, the question wants us to find the effective resistance, that is the total resistance through the whole circuit. Now we have combined the 30 and 70 ohm resistor. So the combination of 30 and 70 ohm resistor has given us 21 ohm resistor. Therefore, this circuit will disintegrate into 19 ohm resistor, which was in series, and a combination of 30 and 70 ohm resistor, which has given us 21 ohm resistor. Therefore, the connection becomes 19 ohm resistor and 21 ohm resistor as shown in this particular circuit here. So remember, 21 is just a combination of 30 and 70. Therefore, the 19 ohm resistor is now connected along a 21 ohm resistor, which is a combination of 30 and 70 ohm resistor. Therefore, whenever resistors are connected along each other, the way we have shown in this particular diagram, we call that series connection of resistors. Then we said that for series, whenever resistors are connected in series, to find the effective or the total resistance, you simply take the sum of the resistance of each resistors. Therefore, R effective will be equal to the sum of the resistance through the 19 ohm resistor and the resistance through the 21 ohm resistor, because they are in series connection. So R effective will be the resistance through the 19 ohm resistor plus the resistance through the 21 ohm resistor, which is equals to 19 ohm plus 21 ohm, which gives us 40 ohm. Remember, in physics, a formula is always very essential in any calculation. A formula usually has 1 mark. So don't be tempted to just calculate directly. Include these formulas in your calculation. For example, when you are computing resistance through 30 and 70, because they are in series that is in parallel connection, you have to indicate the formula for parallel connection. Then after breaking down these two, they will form a 21 ohm resistor, which is now in series with the initial resistor, which was the 19 ohm resistor. So again, for series arrangement of resistors, you have to indicate the formula for the series arrangement of resistor. Otherwise, if you don't include the formula, just know that you have lost the mark for the formula. So R effective for resistors in series is simply the summation of the resistance through each of the resistors. Therefore, 19 plus 21 gives you 40 ohm as the effective resistance, or the total resistance, or sometimes we also call it the equivalent resistance through the whole circuit. Therefore, the total resistance through this circuit is actually 40 ohm. So our second example reads that calculate the equivalent resistance for the circuit below. Remember, equivalent simply means the effective resistance or the total resistance through the circuit. So for this circuit 1, we have the 5 ohm resistor and the 7 ohm resistor. You can see that these two resistors are arranged in series to each other. However, a combination of 5 and 7 is arranged in parallel with 8 ohm resistor. So the first step here is just to break down this circuit in such a way that we end up with a circuit that is in series, that is as shown in the end here. So the first step will combine the 5 ohm resistor and the 7 ohm resistor to have a total resistance through the 5 and 7. So because 5 and 7 ohm resistor, they are connected along each other, it means we are dealing with series connection. Therefore, let's find the total resistance through the 5 and the 7 ohm resistor. So because they are connected in series, R through 5 and 7 ohm resistor will simply be resistance through the 5 ohm resistor plus the resistance through the 7 ohm resistor. So we are adding because this is series arrangement of resistors, as we said in our previous class, that whenever resistors are connected in series, you simply add directly. But when they are connected in parallel, you take 1 over R effective should be equal to the reciprocals through each of the resistors. So because 5 and 7, they are connected in series or along each other, we simply add. So R through 5 and 7 ohm resistor will be resistance through the 5 ohm resistor plus the resistance through the 7 ohm resistor. So the formula is very important. After that, we just substitute the values. Resistance through the 5 ohm resistor is just 5 ohm plus resistance through the 7 ohm resistor is just 7 ohm. Therefore, 5 plus 7, you'll get 12 ohm resistance. Therefore, the combined resistance of 5 and 7 is simply the 12 ohm resistor. Therefore, I want to redraw the circuit now combining 5 and 7. So if I redraw the circuit, I'll have this. So we have the 4 ohm resistor, we have the 8 ohm resistor, 4 ohm resistor, and 8 ohm resistor. But we have now combined the 5 and 7 ohm resistor, which has given us 12 ohm resistor. Therefore, we have a combined of 12 ohm resistor. Now you can see that the 12 ohm resistor, which is a combination of 5 and 7, is now in parallel with the 8 ohm resistor, because the 12 ohm resistor is now connected across 8 ohm resistor. So they are connected across each other. Therefore, we are talking of parallel connection of resistors. So because they are connected in parallel, we'll use the formula for parallel connection of resistors, which is usually resistance R through the 12 and 8 ohm resistor is equals to 1 over resistance through the 12 ohm resistor plus 1 over resistance through the 8 ohm resistor, which of course is equal to R through the 12 ohm and 8 ohm resistor, that is the combination of 12 and 8, which are in parallel, will simply be 1 over 12, because the 12 is the resistance through the 12 ohm plus the reciprocal of the resistance through the 8 ohm resistor. So we are using this formula because 12 and 8 are connected across each other, or they are in parallel connection. So if you take 1 over 12 plus 1 over 8, you'll simply get 5 over 24. Therefore, if I take reciprocals on both sides, I'll simply have R through the 12 ohm resistor and 8 ohm resistor divided by 1 being equal to the reciprocal, that is 24 over 5. So R through the 12 and 8 ohm resistor is equals to the reciprocal of 5 over 24, which is simply 24 over 5. Or alternatively, you can also use cross multiplication. You'll just end up with the same value. Therefore, R through the 12 and 8 ohm resistor will give us 24 divided by 5, which is equals to 4.8 ohm. Therefore, Now, the combination of 12 and 8 ohm resistance is giving us 4.8 ohm. Therefore, it means we can as well redraw the circuit so that we'll end up with 4 ohm resistor being connected in series or along a 4.8 ohm resistor. Remember, 12 and 8 is the combination. That is, the combination of 12 and 8 ohm resistor has given us 4.8. So it means the 4 ohm resistor will be in series with a combination with the resistor formed by a combination of 12 and 8, and that resistor is actually the 4.8. Therefore, we have 4.4 ohm resistor being in series with these two. That is a combination of these two, which actually gives us the 4.8 ohm resistance. Now, the 4 ohm resistor and the 4.8 ohm resistor are actually connected along each other. So this is series connection. So for series connection, R effective is equals to the summation of the resistance through each of the resistors. So R effective is equals to R through the 4 ohm resistor plus R through the 4.8 ohm resistor, which is just 4 ohm plus 4.8 ohm, which gives us an effective or an equivalent or the total resistance through the circuit of 8.8 ohm resistance. So that is how to behave. So the most important thing to notice that you first of all break down the circuit in such a way that you end up with a circuit that is in series. So we began by combining 5 and 7, those that were in series, so that they give us a total of 12 ohm resistor. After that, the 12 ohm and the 8 ohm resistor are of course in parallel connection. As you can see, 8 and a combination of these two are across each other, so that is parallel connection. Then you combine the 12 and the 8 so that you have one resistor. So the combination gave us 4.8 ohm resistor. Now we remain with 4 ohm resistor and the 4.8 ohm resistor, which are in series. Therefore, we just add 4 ohm and 4.8 ohm, which gives us a total of 8.8 ohm resistance, which is the equivalent resistance of the circuit, or simply the effective resistance or the total resistance of that circuit. Next, we want to look at another example. So this example reads that 3 resistors, 2, 3, and 4 ohm are to be connected to a cell such that they have a least effective resistance. So Roman 1, we are required to draw a circuit diagram to show how they can be connected to achieve this. Remember from our previous classes, we did say that when resistors are connected in parallel, that is when they will give the least effective resistance. But when resistors are connected in series to each other, they always give the greatest or the largest effective resistance. Therefore, because the question is asking us to draw a circuit showing that how the resistors can be connected to achieve this, so to achieve the least effective resistance. So in short, the question is just asking us to draw a circuit showing the 3 resistors connected in parallel with each other, because when they are connected in parallel, that is when they give the smallest or the least effective or the total resistance. Therefore, so this is the arrangement that will give us the least effective resistance. That is the parallel arrangement of resistors. So parallel arrangement, we did say that you arrange the resistors across each other and across the cell or the battery that we have shown in this diagram. So this is the arrangement. The parallel arrangement is the one that will give us the least effective resistance or the least total resistance. So you can see my 3 resistors connected across each other and across the cell. So again, this is just one cell because they have talked of a cell. So this represents one cell because this is the positive terminal. Then the smaller bar represents the negative terminal. Roman 2, they want us to determine the least effective resistance of the 3 resistors. So for least effective, we simply use the formula for parallel arrangement. So for parallel arrangement, 1 over R total or R effective will give us 1 over R through the 2 ohm resistor plus 1 over R through the 3 ohm resistor plus 1 over R through the 4 ohm resistor. So this is the formula that we use to find the total or effective resistance for resistors arranged in parallel. Therefore, 1 over R total is equals to 1 over resistance through the 2 ohm, that is the first resistor. Its resistance is just 2, plus the reciprocal of the resistance through the second resistor, which is the 3 ohm resistor, plus the resistance through the third resistor, which is 4 ohm resistance. Therefore, if you take a half plus a third plus a quarter, you will simply obtain 13 divided by 12, 13 divided by 12. So that means 1 over R total, that is 1 over the reciprocal of the effective or the total resistance, is equals to 13 over 12. So if I want R total, I'll simply take reciprocals on both sides. Alternatively, you can also just do cross multiplication, so you'll end up with this. So if I take reciprocal on this side, I'll have R total over 1, which is just the same as R total, being equal to the reciprocal of 13 over 12 is actually 12 over 13, which gives us a value of which is approximately 0.9231 ohm. Again, remember that in physics, if you want to approximate a value, it is always advised to leave your value correct to 4 significant figures. So this is correct to 4 significant figures, that is 0.9231. Remember, 0 is not significant because it is occurring to the left of a number. In case you want to know how to differentiate between significant when 0 is significant and when 0 is not significant, just review our lesson that we did on measurement 2. That is, just go to Form 2 work, you'll find lessons on measurement 2. That is where we discussed when 0 and 0, that is when 0 will be significant and when 0 will not be significant. Then Roman 3, they want us to determine the greatest effective resistance of the 3 resistors. So remember, the resistors will always give the greatest or the largest effective resistance or the greatest total resistance whenever they are connected in series with each other. Therefore, we know that for series connection, that is the one that will give us the effective resistance, as we said in our previous class. Therefore, to obtain the greatest effective resistance, we simply add the resistors. We assume the resistors were connected in series with each other. Therefore, for series connection, we did say from our previous class that R total will be equal to R1 plus R2 plus R3. Therefore, we talk of resistance through the first resistor, which is the 2 ohm resistor, plus the resistance through the second, which is the 3 ohm resistor, plus the resistance through the third, which is the 4 ohm resistor, which is simply equal to resistance through the 2 ohm resistor is 2, resistance through the 3 ohm resistor is 3 ohm, resistance through the 4 ohm resistor is 4 ohm. So 2 plus 3 plus 4, you will simply obtain a total resistance of 9 ohm. So that is the answer for Roman 2. Then Roman 4, that is for Roman 3. Then for Roman 4, they want us to show that for any 2 resistors R1 and R2 connected in parallel, R total is equals to the product of the individual resistances divided by the sum. So R1, R2 divided by R1 plus R2. So we derived this equation in our first, I think it was the second lesson of current electricity 2, but we can just redo it here. So for parallel, because they are talking of 2 resistors in parallel arrangement, we simply have, we know that for parallel arrangement, 1 over R total or R effective resistance must give you the sum of the reciprocals of the resistance of individual resistors. Therefore, 1 over R total is equals to 1 over R1 plus 1 over R2. So we are using this formula because we are told they are connected in parallel. So from here, I'll simply find the LCM on the right hand side. So the right hand side, the denominator, I have R1 and R2. So the LCM is just their product, R1 times R2. Then R1 goes into R1, R2, R2 times, because R1 will just cancel with R1, so that I remain with R2, plus R2 goes into R1, R2, R1 and R, that is R2 and R2 will cancel, so that I remain with R1. Therefore, R2 goes into R1, R2, R1 times. Then from here, this is just the same as saying we can start with R1 plus R2. Remember, for addition, there won't be change of any value. So let me start with R1 plus R2. So it's just the same as R2 plus R1. It's just the same as R1 plus R2. But I'm just rearranging so that I get this format here. So R2 plus R1 is the same as R1 plus R2, of course, over R1, R2 is equals to 1 over R total. Therefore, if I want to make R total subject of the formula, I'll just find the reciprocal on both sides. So if I take the reciprocal on this side, the reciprocal of 1 over R total is just the same as R total over 1. Then the reciprocal of R1 plus R2 over R1, R2 is just the same as the reciprocal is R1, R2 over R1 plus R2. Then we know that RT, R total over 1 is just the same as R total, which is equals to this value here, which was the product, that is R1 R2 divided by R1 plus R2. So we have actually showed that for any two resistors connected in parallel, R total can be given by this particular formula here. Then last exercise here that I do recommend you should try at your own free time to gauge whether you have understood the examples that we have just tackled. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that self-discipline dictates your level of success. So the quote is reminding us about the importance of staying disciplined in everything we do. For instance, as a student, you need to stay disciplined to your personal study timetable. That is, you don't have to wait for your teacher or for your guardian to remind you about studying time. Also, in real life, you have to set daily personal goals and purpose to achieve those goals, because your long-term success will be the sum of your daily achievements. Remember, if you add your daily achievements, the total or the sum of your daily achievements will amount into your long-term success. Therefore, ensure that each day at least you're achieving something small. And lastly, recall that true success can only take place in the presence of hard work, patience, commitment, consistency, and self-discipline. So in case you have any challenges in working out any of these particular questions in the exercise, feel free to drop a comment specifying the questions that you have the challenge in. And of course, as usual, I'm always here to try and help where possible. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll always get notified. If you know any student that you honestly think could benefit from this content, kindly refer them to Kind Tuition Academy. Until next time, this is Kind Tuition Academy.